The evolution of artificial intelligence, a deep dive into machine learning and neural networks. Hello everyone, and welcome to a brand new video on the channel. Today, we are going to talk about the evolution of artificial intelligence, a deep dive into machine learning and neural networks. Before we get started with the video, don't forget to smash the like button, share the video, and subscribe to the channel. Now, let's get started. Every minute, we find new ways to incorporate various forms of technology into our everyday lives. In order for businesses to stay up with the needs of customers, they are increasingly relying on machine learning algorithms to simplify processes and make things easier. Despite the fact that artificial intelligence, machine learning, deep learning, and neural networks are all related technologies, the phrases are frequently used interchangeably, which leads to confusion about the distinctions between them. Artificial intelligence makes up the entirety of the system. The field of artificial intelligence encompasses a subfield known as machine learning. Deep learning is a subfield of computer learning, and neural networks are the basis for deep learning algorithms. Deep learning is considered to be a subfield of machine learning. Neural networks can be differentiated from deep learning techniques, which need to have more than 3 node layers, due to the fact that depth refers to the number of node layers. The term artificial intelligence, which refers to computer programs designed to replicate human intelligence and cognitive abilities like learning and problem solving, is the most all-encompassing of these 3 ideas. Artificial intelligence refers to computer programs designed to simulate human intelligence and cognitive abilities like learning and problem solving. Artificial intelligence makes use of predictions and automation to optimize and solve complicated processes that have traditionally been the responsibility of humans. Recognizing faces and voices, making decisions and translating are a few examples of the tasks that fall under this category. While the other 2 are considered to have strong artificial intelligence, Annie is considered to have weak A. Weak artificial intelligence, I, is defined by our company as the ability to achieve a single objective, such as triumphing in a chess match or locating a certain person in a collection of images. Natural language processing, NLP, and computer vision are 2 examples of Annie that enable businesses to automate tasks and power chatbots and virtual assistants such as Siri and Alexa. Annie also enables consumers to interact with virtual assistants such as Siri and Alexa. The use of computer vision is helping to advance the development of self-driving cars. Stronger forms of artificial intelligence, such as general artificial intelligence, GAI, and artificial general intelligence, ASI, contain more prominent human characteristics, such as the ability to understand tone and emotion. Strong artificial intelligence can be defined by its ability to compete with humans. Artificial general intelligence, AGI, would be on par with another person, whereas artificial superintelligence, ASI, which is often referred to as superintelligence, would be superior to a human being in terms of intelligence and ability. Although strong artificial intelligence does not yet exist in any form, research into this field is still ongoing. Over 1/3 of companies throughout the globe are now utilizing artificial intelligence, i.e., and an additional 42% are conducting research on the technology. It is possible that the introduction of generative artificial intelligence, which uses powerful foundation models to train on enormous volumes of unlabeled data, would be able to be adapted to new use cases, deliver flexibility and scalability, and possibly significantly accelerate the adoption. This would be the case because generative AI employs powerful foundation models to train on enormous volumes of unlabeled data. Initial studies conducted by IBM demonstrated that, in contrast to traditional AI, generative AI is capable of reducing the amount of time necessary to generate value by as much as 70%. I may provide your firm with a competitive advantage, regardless of whether you choose to use meal-based AI applications or foundation models. Automating processes like customer service, supply chain management, and cybersecurity can help a company fulfill the expectations of its consumers both now and in the future. Integrating customized AI models into workflows and systems can also be helpful in this regard. To ensure that you are making use of high-quality data and gaining the most significant possible advantage over your competitors, the first step is to select the appropriate data sets as you are getting started. In addition to this, you'll need to construct a hybrid, I-ready architecture that is capable of consuming data in any location it is stored, including mainframes, data centers, private and public clouds, and at the edge of the network. Because of the potential for reputational damage and financial penalties for a business, the artificial intelligence you use needs to be reliable. Misleading models, as well as models that integrate prejudice or hallucination, can be detrimental to the consumer's privacy, data rights, and trust, all of which can be expensive to fix. It is imperative that your artificial intelligence be explicable, impartial, and open to scrutiny. The application of artificial intelligence in the form of machine learning makes it possible to optimize processes. It is designed to help you make more accurate predictions than you would be able to achieve by relying solely on your intuition alone when it is correctly configured. Machine learning is used by businesses like Amazon, for example, to provide product recommendations to individual customers based on what that consumer has previously researched and purchased online. Traditional or non-deep machine learning necessitates the participation of a human instructor in order for a computer system to be able to recognize patterns, learn, carry out particular tasks, and generate accurate results. It is typically necessary to have more organized data in order to learn from it, as human specialists are the ones that design the feature hierarchy in order to comprehend the distinctions between the data input. The third sort of machine learning is known as reinforcement learning, and it is the process by which a computer acquires knowledge by interacting with its environment and receiving feedback in the form of rewards or penalties for its action. A form of machine learning known as online learning involves continuously updating the EL model in response to the addition of fresh data. Deep learning eliminates a significant portion of the requirement for manual human interaction by automating the majority of the process of feature extraction. In addition to this, it enables the utilization of vast datasets, which is how it got the name scalable machine learning. This feature is exciting as we examine the utilization of unstructured data further, particularly given that it is believed that over 18% of an organization's data is unstructured. Currently, we are investigating the usage of unstructured data. The ability of a deep learning model to accurately cluster inputs is made possible by the observation of patterns in the data. Using the same example as before, we may classify pictures of pizzas, burgers, and tacos according to the similarities and differences that are visible in the pictures. Deep learning models require more data points to be input in order to enhance their accuracy, whereas machine learning models require less input due to the underlying data structure of their training data. Deep learning is most frequently utilized in business settings for the performance of more complex tasks, such as the creation of virtual assistants or the identification of fraudulent activity. Neural networks are a type of machine learning that serve as the foundation for deep learning approaches. They are also known as artificial neural networks, ANNs, or simulated neural networks, SNNs. They are referred to as neural because they mimic the way neurons in the brain communicate with one another, which is why the term neural is used to describe them. An input layer, one or more hidden layers, and an output layer are the components that make up the node layers of neural networks. Each node in the network represents an artificial neuron, complete with a weight and a threshold value that determines how it links to the subsequent node. If the output of a single node is greater than the threshold value, then that node will become active and begin transferring data to the subsequent layer of the network. In the event that it is lower than the threshold, data will not be transferred. Training data are used to train neural networks, which ultimately results in an increase in the accuracy of the networks over time. Once the learning algorithms have been fine-tuned, they change into powerful computer science and artificial intelligence tools by allowing us to swiftly classify and cluster data. This enables us to do things like identify patterns in the data. When employing neural networks, it is possible to solve tasks involving speech and image recognition in a matter of minutes rather than hours. The search algorithm that Google uses is an example of a neural network that is widely known. The deep in deep learning refers to the depth of layers in a neural network, which was discussed in the description of neural networks that was presented earlier, but bears repeating because it is important to understand the concept. A neural network that consists of more than 3 layers, including the inputs and outputs, is known as a deep learning algorithm. That's a wrap on the video. I hope you liked it. If you did, let me know by giving it a thumbs up and do not forget to subscribe. Thanks for watching. See you next time.